Hi everyone, I'm Shubham Garg and welcome back to the lecture series of DSCH. So I know I'm recording this video after a long time, but we will continue with more circuits of DSCH, alright? So today the circuit we are going to see is a combinational circuit, and you may have guessed from the circuit diagram on your screens, we are talking about decoder. So yes, in today's lecture we are going to see how to create and simulate 2:4 decoder. Alright, so first of all I will just show the demo of a decoder. So you can see here this is a circuit diagram. So decoder has two inputs A and B because we are talking about 2:4 decoder, and it will be decoding the output into these four LEDs. That is, for each combination one of the LED will glow. Alright, that is, that output will be active 1 and all the other outputs will be 0. Alright, so I will just run the simulation, and you can see when both are 0 0, this first LED is 1 and all the other LEDs are 0. Similarly, when A is 0 and B is 1, this second LED is 1 and all the other LEDs are 0. Similarly, when you can see A is 1 and B is 0, this third LED is 1 and all the others are 0. And when both A and B are 1, this fourth LED is 1 and all these three are 0. Alright, so let us see the truth table and then we will see how it is actually working. Okay, so I will just stop the simulation right here. So let us quickly make a truth table. So I will be having the inputs. Okay, the inputs A, B, and the outputs will be let's say the outputs are Y0, Y1, Y2 and Y3. So these four are the outputs. So when we talk about the inputs, the input combinations will be like this: 0 0 0 0 for 0 0 1 1 for A and 0 1 0 1 for B. Alright, so these are our input combinations. Now talking about the output, what is happening when both A and B are 0, Y0 is glowing and Y1 is not glowing, and all the others are not glowing. Okay, so it is like this is 1 and this is 0. Similarly, this one is also 0 and this one is also 0. Alright, similarly, when A is 0, B is 1, it is 0, 1, 0, 0. Alright. Now next is 0, 0, 1, 0, and in the final case it is 0, 0, 0, 1. So you can see basically it is performing in a diagonal fashion. That is, when AB is 0, Y0 is 1. When A is 0, B is 1, Y1 is 1. Okay, now let me tell you one thing, that this A 0, 1 and 1, 0, it can be inverted. That is, A can, we are talking about here A is 0 and B is 1. So in this case Y1 is 1. But as you have seen in the simulation, when A was 1 and B is 0, then Y1 was 1. Okay, so that is just the naming of the inputs. So they can be vice versa because A and B both represent just the inputs. So it's alright. Okay, and basically now let me tell you what is the, okay, first of all, let me zoom in the table a bit. Yeah. So here now you can see the table clearly. So now what is actually happening is on this on these terminals A and B, we are basically getting these things. That is, Y0 as the output is basically we are getting these four combinations. That is A dash B, A bar B bar. Y1 we will be getting A bar B, or we can set it to A B bar, basically because these four are output. So that's why A and B can be 0 and 1 and the output can be this, or A and B can be 1 and 0 and output can be this. Okay, so similarly Y2 will be A B bar, alright, and Y3 will be AB. Alright, so that's why you can see from this thing that y0 is a bar b bar. Okay, so that is the value of a and value of b is 0 0 in this input. So y0 becomes a bar b bar, that is y is equal to 1, y0 is equal to 1, and we can see y1 is equal to a bar b. Okay, so when we do a bar b, a bar is 1 and 1 and 0 is 0. Similarly, we can calculate y2. Okay, you can basically see here when we are taking this case. So we are taking this case a and b, it is 0 0. So when we calculate y0, we get y0 is a bar b bar. All right. So here in this case a b is 0 0. So a bar and b bar is 1. So that's why y0 is 1 and 1. So that's why we get y0 as 1. Similarly, when we talk about y1, y1 is a bar b. All right. So when we talk about a bar b, we can see that a bar is 1. Okay, in this case, when a and b are 0 0, a bar is 1 and b is 0. So a bar dot b, that is 1 dot 0. So this is the case, and that's why this output is 0. All right. So similarly, when we talk about y2, y2 is a b bar. Again, a is 0 and b bar is 1. So 0 into 0 and 1, we get 0, and y3 is ab. So a and b both are 0 0. So when we do a and b, we get 0. So that's how we get all these outputs. Similarly, you can do for all the other cases, that is 0 1 1 0 and 1 1. All right. So this is how a decoder works. Now let us go back to the simulation. You can see here that whenever I run the simulation, you can see first of all when both a and b are 0 0. So what is happening? A and b are 0 0. So a is 0. There is a 0 input from the a to this AND gate. That's why this is not active. Okay, and since a is 0, a bar becomes 1. All right, and you can see a bar is having output connected to this AND gate and this AND gate, and a was only having the output to this AND gate and this AND gate. All right, so this blue line, this is not activated because it is 0. Similarly, when b is 0, due to this inverter, since b is 0, b bar becomes 1. So the gates to which b bar is connected becomes active. The wires, that is these red ones, that is one this wire and other one this wire. Now you can see only this AND gate, that is the first one AND gate, is the only AND gate having both the lines which are active. All right, that is both the lines in red color, that is in both these lines the signal is flowing, signal is there. Okay, input value is there. Otherwise in all other gates there is either only one input active or no input is active. So that's why in this case this LED glows, the first one. Similarly, let us take another case, that is a is 0 and b is 1. So you can see when a is 0, again a bar is 1, and in this case this AND gate is active and also this AND gate is active, like this line. And similarly in this when b is 1, b bar is 0. So when we see b is 1, when b becomes 1, first of all this AND gate becomes active and this AND gate become active. So what happens here, that this is the second one, this AND gate is the only one which is getting active, which is having both the lines as active in this case. So that's why this LED starts working. All right. So this is how a decoder is working. Basically, decoder is actually a lot useful. First of all, we use the encoder circuits. We will be discussing that in most probably in the next videos. So we are using encoder circuits. So after encoding, we need to use decoders. Also, there is a famous circuit, that is BCD to 7-segment display. So that is when we give the input into binary, it is basically giving the output as the 7-segment display, LED display. Okay, so in that also a decoder is used, and in communications, as we use encoder, we use decoder to decode that as well. So these are the uses of decoder. So now I hope the working and truth table and the simulation of decoder is clear. So now let us delete all this and start making the decoder from scratch. Alright, so I will first stop the simulation. Alright, so I am going to delete everything. So here I have deleted everything. Now you can see here you need to first of all take two inverters. Okay, first is this one and second is here. Alright, and now we need 4 AND gates. Okay, one more thing, you can use NAND gates also instead of AND gates, basically because we need to just select a particular output, that particular output should be 1 or 0, so you can use NAND gate as well. We just need that behavioral functionality of AND gate or NAND gate, that is we need to basically perform the AND operation within the input. Alright, so on taking NAND gates, only the inputs will be just inverted again. Otherwise, the logic will be the same. Alright, so now let us take another AND gate and the third AND gate and here the fourth AND gate. Alright, so we have all of our AND gates and there these are our inputs. This is the first input and this is the second input. So here we are going to change the name of the inputs to A. I will just make the connections. Okay. Okay, by mistake I chose this as an AND gate. So we need AND gate here. Yeah. Now, one more thing, I will connect the LEDs at the outputs. So here this is our first LED. This is our second LED. The third one and fourth one. Now those of you who are wondering that I was having some text written in front of these LED. Okay. Yeah, when I showed the video I had some text written in front of this LED, so for that you just need to go to advanced and here you will find this box in the miscellaneous. So you can just drag and drop the box and double click on it and you can here write anything you want like K dash B dash or anything basically you want. Okay, so I'm just changing the name of these LEDs, that is Y0, Y1, Y2 and Y3. Alright, so here I'm going to copy this box as well. And I'm going to rename them. Okay, first was A bar B. Now let's name this as A bar B. Okay, we will make connection basically according to that only, and this will be AB bar and this will be AB. Alright, so first is A bar B bar. Alright, so that is the output of both the inverters. Okay, so we will connect it here. This is for A bar and that's the output of B bar. Alright, that is A bar B bar, and now we are going to connect A bar B. Okay, so this is our A bar and here we have B. Okay, I don't see a connection here. Let me just delete this. Yeah, I will just add the NAND gate again. Okay, now it seems fine. So I will just copy this. I guess I need to add the switches again as well. So I will delete these switches, and here let's add button once again. Yeah, you can see here now it has this connection thing. So I will name it as a I will name it as a, and I will add another switch, another button basically, and I will name this as B. And here I'm going to make the connections again. So now you can see it is connected fine. All right, and here we need to connect it to B. All right, next thing is A, B bar. Okay, so here let us connect it to A. So this is connected to A, and this needs to be connected to B bar. All right, and now finally we need to connect it to A and B. So here we can see that this is A, and finally this is B. All right, so we have made the connections of the decoder, and let us try to simulate the program. So I will just run the simulation, and we can see when both are 0, y0 is 1, when A is 1 and B is 0, this is 1. All right, when both of these are 1, then this LED glows, and in the final case when A is 0, B is 1, this LED glows. So this is how a decoder works. So this is a 2:4 decoder. Similarly, we can make a 3:8 decoder as well. All right, that will be having 8 cases. Okay, and basically same way the truth table will work the same way, and we'll be having that much NAND gates or AND gates. Okay, so this is how a decoder works. You can try a 3:8 decoder as well. It's just a repetition. Okay, so this is all for this video. See you guys in next video.